This video is designed to help you with exercise 4b. This is the second part of the moments chapter, and we're moving on from doing a single moment acting around a particle to multiple moments acting at once, and then we're going to sum them up and get a resultant moment. So here's a diagram to explain what I mean. You've got a pivot point down here at P, and then there's three separate moments acting around this particle, which I'm going to try my best to colour in with the mouse. So that one we're going to call number 1. That's the second one in the middle. And here's one as well. Okay, so we're going to label these up. We're going to calculate them individually and then sum them up. So moment number 1, I need the two things that I need. The force is 5. The perpendicular distance is 1 plus 2, which is 3 meters. Times them together, you get 15 Newton meters. And the direction, if you pretend that you've got a clock face with P in the middle, you're going round clockwise. Moment number 2, the force is 4 newtons, the distance is 1 meter, so you get 4 Newton meters. This time we're going around this way, that's anti-clockwise. And then for the third moment, it's 1 meter away, it's 3 newtons of force, so 3 Newton meters, and again around this way, so anti-clockwise. Okay, if we're going to sum these together, what we need to do is fix a positive direction, and then anything against that direction is going to be negative. Now normally you'd choose the direction that ends up with a positive force, a positive moment, so it looks like clockwise is the one to take as positive this time. Then 15 Newton meters is positive, the anti-clockwise moments are negative, add together and you get 8 Newton meters. And the direction overall is clockwise. Okay, we could have said minus 8 Newton meters anti-clockwise, but that's the same. Reversing the direction makes your moment negative. Okay, second example. There's 2 moments acting. They're both at a nice perpendicular distance. No angles to worry about. So acting around P, you've got a moment up here, a moment down here. The first one is just 5 times 2. That's going to be 10, and it's going to be clockwise around that way. Moment number 2 is 5 times 4. That's 20 Newton meters, but this time anti-clockwise. So to end up with a positive resultant moment, I'm going to take anti-clockwise as positive this time. Subtract, and 10 Newton meters anti-clockwise is the resultant moment this time. Okay, last one. If there's angles between your force and your pivot point, then you're going to need to do some trigonometry to work out the perpendicular distances. So this time I have got 3 moments. 2 of them need a bit of trigonometry. This one we'll call 1, this one we'll call 2, this one we'll call 3. Moment number 1, the force is 5, but I need the perpendicular distance, so you need to draw that on, acting straight towards it. Looking in this right angle triangle down here, 4 meters is this hypotenuse, and this is the opposite side to the 80, so this distance would be 4 sine 80. Times it by the force, you get 20 sine 80 Newton meters, and the direction of that is going to be clockwise, around that way. Okay, moment number 2 is the easy one. It's just 6 newtons, 3 meters away, 80 Newton meters anti-clockwise. And moment number 3, a bit more trigonometry, it's 4 newtons, there's the leg, there's the perpendicular distance, it's 3 times sine 40. Times together, you get 12 sine 40 Newton meters. That one's going to be anti-clockwise as well. And then summing them up all together, clockwise is what we're going to take to be positive. That's going to produce the biggest positive moment. So positive, negative, negative, minus 6.01 Newton meters clockwise. But that's equivalent to avoid the negative, we can write it as 6.01 Newton meters anti-clockwise.